Alright, let's look at project network backward scan, critical path and slack. Now, what I really want all of you to recall is how to determine the earliest start time or earliest starting time, EST, using forward scanning. Now, today I'm going to introduce the latest start time using backward scanning, and you'll be able to identify the critical path and the slack time available for project network. So forward scan, I went through it with you on Friday. This 3-bit sounds like a lot, but it's pretty much all tied in together. Now, just to recall, project network. A project network is a directed graph or digraph. Alright? It's a series of vertices, nodes, or edge arcs to represent tasks or activities required to complete the project within a certain time. So I've given you an example, construction of a house or making a cup of coffee. Alright? Now, on Friday, I show you forward scan, which is a systematic approach to find the EST or the earliest start time. What we're going to do is going backwards. We have moved forward from the start to the end. We're going to move from the end all the way back to the start so that we can work out what the latest start time is. Alright? So it's quite important we are using the same network as Friday. So there's no extra handout for today, Cynthia. Same. So the two systematic approach, forward scan and backward scan. So quickly going through forward scan. You look at the start of the vertex or node, the start vertex or start node. Enter 0 at the top of the vertex. And then the earliest start time for any task is the maximum time taken to reach the task. So if you have 2 or more edges or arcs joining a vertex, the highest total time is chosen as the EST. So you must work out the EST, and the entry in the final finishing node will give the minimum completion time for the project. Alright? So EST is linked to the minimum completion time of the project. Everyone happy with that? So now you know what minimum completion time for the project is based on the EST. Just quickly look at the forward scan process again. Same network that I showed you. So I start off with the start. Normally this is a start from the left and work through to the right. That is the end. Now, start is always 0. From here, going to the next node on the next vertex, you see that project A must happen, and this could be 6 hours or 6 days. So you write down the 6 there. Alright? From here, this node or this vertex here, you have got project B and project C. And project B is 12 days or 12 hours. Project C is 14. So therefore you know from here to here, before E can start, you must complete project C first. Alright? So therefore, the earliest start date for E is C has to finish, which is 14. So therefore, you got to pick 14, which means B. You can move B a little bit. B has a bit of a slack time, bringing the word slack in there. Alright? Then, if I go to this node here, I've got project D and E going in. G and H cannot start until D or E completes. Alright? So if D, going from here, D is 21 days or 21 hours, you know that to reach here, it has to be 27 days or 27 hours. Whereas for E, E will take a bit longer. E is 18, 18 plus C, completing C, which is 14, which is 32. So therefore, maximum 32 is there. So before anything G and H can start, you must complete A, D, B, C, and E. Alright? Now one word that I'm going to use, which I have not used on Friday, is immediate predecessor. D and E is the immediate predecessor of H. D and E is the immediate predecessor of G. Alright? So immediate is straight away, you have to have that. These are all predecessors, but those are the immediate predecessor when you are creating the network. All right. So this is the process I go through, going through the whole network until I find that this is completion time, 60 hours, minimum completion time, 60 hours. Everyone happy with that? So you would have tried some exercises over the weekend. Now, what I've done, the process is called the forward scan, moving forward and actually achieving the minimum completion time. From here, I'm going to move backwards. All right, move backwards, scanning backwards. The purpose is to find a critical path. The critical path is where there is no slack time. The path that you must complete before you delay the project. If not, your project will be delayed. All right, let's think about how we do it. So backward scan to determine the latest start time. You start at the finishing vertex. So you start from this end, you slowly scan backwards. Look at all the duration, and you have to ignore the early start time. You are going to work up the later start time. Now, work backwards by subtracting the task time taken and enter the lowest start time, LST, the latest start time, into the vertex. When you have more than one edge or one path to the previous vertex, subtract the task time from the previous latest start time, one at a time, and enter the lowest. This time, you are entering, when you move back, you are entering the lowest latest start time into the vertex. All right? When you go forward, it's the maximum, the highest. When you go back, it's lowest. All right? Forward, highest, back, lowest. All right? Later start time, LST, L associated with lowest, L and L. All right? So repeat the process until you reach the starting node. So using the same network, let's start. All right? Start from backwards. You've got 60 here. Now, if we ignore everything else, this one, is there anyone coming back? There's only one edge or one arc. So therefore, it's pretty straightforward. 60 minus 17 will give you 43, right? So write down 43 here. Now, to go from here to here, to go from here to here, what happened is you do have one vertex going back and one vertex going back there, correct? So here you've already worked out the latest starting time. 43 minus 11 will give me 32, all right? Here is 60 minus 12. 60 minus 12 will give me 48. So what is the lower? Lower one is 43 minus 11, that'll give me 32. So you input 32. Oh, actually, I didn't do that first. I did this one first. Doesn't matter. So if you want to do it this way, this is going back straight through here. There's only one arc. So it's 43 minus 12, which is 31. All right? And then go back there. That's 32. Okay? See that the way I did this, 43 minus 12, which means what happened is I could possibly move this a little bit because there is some slack. I'll talk about slack time in a few minutes. But here, you can see that from here to here, the latest start time for H will be 32. It's the same as the latest start time, yep?
Why was that one 32?
Because if you look at this, all right, I have got the latest start time here, taking away the task time, which is 12. So if 60 take away 12 is 48, and then 43 take away 11 is 32, I pick the lowest. So I go back and pick the lowest. Alright? So therefore there's 32 there. Alright? And here is 31 because there's only one arc going in. Yeah? Alright, let's continue. Here, of course, you know that 32 minus 21, that's only one arc going in, you can work that straight away. However, you need to think about here and here. What do you do? Alright, 32 minus 18 and 31 minus 16. What will I get here? If I have 32 minus 18, what is here? And what is 31 minus 16, what is here? So 31 minus 16 will give me 50, correct? 32 minus 14 will give me, 18 will give me 14. So which one do I pick? 14? So that's how you do it. Alright? 21 minus 6 give me 32 minus 21 give me 11. Right? So now next one, alright. When we come to the last bit, 11 minus 6 is 5. 14 minus 12 is 2. 14 minus 14 is 0. So when you go back, you always must make sure that that time there is 0. So the start of the backward scan, you've got to use the earlier start time, and then work backwards, you must have the start time of 0. Alright? So now if you go through all the vertices, you can see that there are later start time of 31 versus the earlier start time of 30. Later start time of 11 versus the earlier start time of 6. Later start time of 14 and earlier start time of 14. Alright? Those are important. Before I go on to that, let me show you. So to calculate the later start time, 60 minus 12 will give me 48. 43 minus 11 will give me 32. So I choose a lesser value. Everyone happy with that? Now, so here, the earliest stage, let's look at this from A before D starts, okay? Let's look at A to D. Alright, project A and project D. You know that D cannot start until A has been completed. Correct? So now, earliest this stage can be reached in 6 hours into the project. 11 is the latest time we can reach and still complete the project in 6 hours. Which means, if I delay this, I can actually have the slack between here. I can move about from A to D before G and H start. This path here, that's a little bit of a movement. Alright? We could delay that project D before we actually need to, before we affect the whole completion project, the minimum start time of 30. Alright? Now, however, if you look at this, 14 and 14, earliest this stage can be reached is 14 hours into the project, which is also the latest time we can reach this stage and still complete the project. So, I must always, before E can start, I must always work on C first. C has to be completed before E can start. Alright? Although there's a little bit of slack between B. Alright? B can be moved a little bit, but C and E cannot move. If C and E move, what will happen is the whole project will be affected. Alright? So now, if you look at all the vertices where the latest start time take away the earlier start time is 0. That is the critical path. Alright? Now, critical path is when ESD equals to LSD. And this is called the critical path. And the critical path is, in this case, is CEHJ, and minimum completion time is 60 hours, which is what we have worked out. So in the exam itself, if you were asked to actually indicate on the graph what is the critical path, remember, scratching this out. All right? This is what you should do. To very clearly indicate that that is a critical path. So you must complete C, E, H, and J on time. All the others, you've got room for movement. But these 4 projects, you cannot move at all. See that? So you can see, just take the most straightforward example, which is before E and F can start, you have to finish C first. Because C is 14 hours, B is 12 hours. So you actually have a little bit of movement, the 2 hours that you can move. Correct? Yeah? So this is what critical path is. Alright? Now, I'll talk about float or slack. Float or slack, interchangeable, these 2 words, alright, is the maximum amount of time that a task in the project can be delayed without affecting the completion time of the project. So if you go back to the previous one, B, let's say everything started at about 8 a.m. in the morning, alright? You know to get to E, 8 plus 14, well, 10 hours, 10 p.m., right? So here, you know B has to reach the same point at 10 p.m., right? So, however, does it have to start right on time? Same as C? No, it's got the time, you can move it around. Correct? Yeah? So you got to think about how the slack could affect the whole network. Generally, slack, it does not affect the whole network. Slack is the time that you can move the project around without affecting the minimum completion time of the project. All right. Now, all tasks on the critical path are called critical tasks and have 0 float time. That's important. Task on the critical path, no float time, and it's called critical task. So generally in the exam question, you will have to find out a critical path, and then from the critical path, they will ask you a question about assignment of people working on the project, and or sometimes they will say certain critical task, the time required has reduced, and then C, it would affect the whole minimum completion time. I'll go through some exam style question with you a little bit later. Now, all tasks not on the critical path are called non-critical tasks and have a float time of greater than 0. So the slack time of a task is the time the task can be delayed without affecting the minimum completion time. Now, can you write down the formula? The float for any activities or activity X is equals to the latest start time at the end. Take away the earliest start time of that X and then the duration of X. Alright, think about it. Latest start time at the end of X, take away the earliest start time of X and then take away the duration of X. Some of the questions, they will give you the start of the project and then ask you to work through, say for example, 8 a.m. You have to work through the completion time, maybe 10 p.m. or whatever, it depends, and how it could affect whether the completion time will be extended or brought forward. So write down the last, that formula there. Float for an activity X equals to latest start time at the end of X. Take away the earliest start time, and that's the duration of X. And take away the duration of X. So this is a basic project network that you need to know how to analyze. Forward scan.
So the duration would just be the total of like the edge.
I'll just go back. Yeah, that's correct. The total of the age. I'll go back to that in a few minutes. Callum? Yeah, you need your laptop? So. Alright, now let's go back and have a look at this. So if you write down later start time, take away earlier start time, and take away the duration. Alright? Now, have a look at this. Let's go for project G12. Alright? So, latest, the slack will be the latest start time, which is 60. Take away the earlier start time, 60. Take away 32, which will give, and take away 12, which is duration. So 60, take away 44, which is 16. You got 16 hours of slack time. So this can start anytime within the 16 hours. Yep.
Slack and load times are the same thing?
Yep, slack and float time, they are the same thing. Yep, absolutely. Slack and float, they are the same thing. I use it interchangeably. I'm not sure in the, I'm pretty sure in the exam they use the same thing as well. Slack and float is interchangeable. Alright, so now you can work out the float and slack time for all these projects. Alright, the red one are the critical path, whereas the rest, I've got some float time. I can delay that for 16 hours. G can be delayed for 16 hours before it affects the minimum completion time. Like I, you can only delay it for an hour. Alright, and D, you can delay it for 5 hours. D, like I say, is 2 hours. You've got 2 hours that before I've got to go to the E. Alright? Now, let's have a look at what I've given you, which is this, and see how we're going to answer the question. Alright? So, you've answered the first one. How many activities are required to be completed for this project? Which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 activities. State the critical path and the minimum completion time for the project. I've worked that out, haven't I? Alright. So I've worked that out, the critical path. Now, when you want to state, you just have to write C, E, H, and J. That's all. But if you need to highlight in the network, do that. Scratch it out, alright? Remember, just to scratch it out. That is the way of showing it. Whoever marked the paper, they know, you know what the critical path is. List the critical activities and determine their float. Critical activities, float is 0. So that is sort of like redundant question, but one of the things that they will ask you. Determine the float time for all non-critical activities. Done that for you? Alright. And then, now, part E. If activity D has a float of 5 hours, what does this mean? So you have to be able to explain what does float time mean. Which means activity D 5 hours, which means it can be delayed for 5 hours before it actually affects the minimum completion time. Alright? Now what is meant by the term slack? It's a project that can be delayed before it affects the minimum time. Or the word slack here is a maximum amount of time. Remember the definition. Always remember the definition. It's a maximum amount of time a task in a project network can be delayed without affecting the completion time of the project. Remember the definition of this. Alright? You need to know that. That's important. I've seen a question like this asked before. Now, G. Alright, let's have a look at G. if activity J could be completed in 10 hours, how would the critical path and minimum completion time be affected? So now, instead of 17, it is now, hang on, read the question, in 10 hours. All right, it's in 10 hours. How would the critical path and minimum completion time be affected? So let's say this is 10. All right, so what happened here? If I have going through here to here, 43, I will have 53, and 32 plus 12, that is 44. So here, the completion time will be 53 hours. However, would the critical path be affected? It will not be affected because you are, if you go 53, take away 12, it is not 32, right? So, hang on, 50, sorry, my fault, 53, take away 12, it will be 41, which means that will not be the critical path. This will still be the critical path because 53 take away 10, it will be still 43. Got it? So the answer is the critical path is not affected. And the minimum time will now be reduced to 53 hours. See how I work backwards? So I'm just looking at the critical path first and that point. Because the question asks, how would the critical path and minimum completion time be affected? Not affected. And what else? Okay, here I've made a comment. All right, in real life this could be done by employing more resources to carry out this task. Task J is a critical activity, and the process of reducing the critical activity is called crashing. All right, the word crashing, just for your information. The project commenced at 8:30 a.m. on Monday. Now, this is typical exam question. They'll give you a time and ask you what is the latest starting time for activity F. So let's think about it. The float time for task F, where's F? F is here, all right? Let's get rid of, no. F is here. I'm going to circle F. Oh, shit. I should use a different color, I think. Use a different color. Just to highlight that. F. And that will link to this question here. Alright, what would happen with the latest start time for F? So, now, the float time for task F is 1 hour. And the EST, the earliest start time is 14 hours after the start time. So 14 hours after 8:30, what time is that? You should be able to count. Come on. So 14 plus 8 is 22, which is 10 p.m. correct? And that's half an hour, is 10:30 p.m. So therefore, it can start 15 hours after the start time, which is 11:30 p.m. Yeah, that sort of question will be difficult in the exam question. And then finally, its activity has been delayed by 8 hours, 6 hours, oh sorry, 8 hours. What would the new completion time? So task D is here. So using a different color, task D is here. D is 21. Now, it's D21 and the float time is 5 hours. If it is delayed by 3 hours, so there will be additional 3 hours added to the project. Alright, so think about it. Here, if D is affected by 3 hours, that will actually affect the critical path. Because 11, here is now 24, correct? So therefore, it will affect the critical path, and therefore the whole thing will be delayed by 3 hours, which is 63 hours. So that's all I actually have for you. What I would like you to do is try exercise 7B and 7C. 7B is actually doing a lot of later start time. And the network you use, if you use the same network as exercise 7A, that's fine. Just do that. Use the same network as exercise 7A because you've already worked out the earlier start time. You can just work backwards and find a later start time. Alright? 7C is important. You need to be able to work out the critical path. Alright. So just quick summary of our critical path analysis. So to establish the optimum schedule, we use algorithm to find the EST, earlier start time, and then the later start time without delaying the project, and think about the critical path. And then the others are all flexible, considered as non-critical activities, which have floats and slack. Alright, I'm going to stop here.